In this video clip, I'd like to cover the machining strategy for a part imported from a DXF file using D2nc. So if we switch over to CAD and import DXF, I've got one prepared here called demo. And there we see a bracket with a central hole, 3 slots for mounting, and an outside path. Click Next, and the first thing I want to do is position it to the bottom left. Click bottom left. You'll see it's positioned with the X0, Y0 point at this location. If we just undo that, switch off the auto resizing, and switch off the grid, you'll see the X and Y axis. And now if we click bottom left, you'll see the part move. Switch on auto resize and the grid back on. So now if we switch over to offset, what we want to do is plan the three major parts: the central hole, the slots, and the outside path as 3 different operations in machining this. The first thing we'll do is set a tool diameter, 0.25, and we're going to pocket and select the central hole. And then we'll do the pocketing of that. Next step, we'll select the 3 slots, and we'll offset those to the inside using the same tool. And then finally we'll select the outside path and offset that to the outside using the same tool diameter. So now we have the shape is offset, all using 0.25 tool, a pocket, offset to the in, offset to the out. And we can proceed with creating the actual G code to machine that. Going through constraints, we set our safe Z, maximum feed rate, select the material, and go over to path. Because these are all pre-offset paths, we're going to just contour them. The first step in contour, what's different from the previous releases of D2nc, is that we can now select partial shapes for machining. And we can only select partial shapes using the local shape. Local shape means that the shape that you're going to cut is local to the machine queue rather than the global shape, which is the entire shape entry, which would be everything you see. So we select local shape, select no objects, and select just the pocket, and move it into the local shape. We can now apply machine parameters just for this shape. So if we go, this is a plate of aluminum that's 3/8 of an inch thick. And we're going to create this pocket a 1/4 inch, so to a depth of 0.25. We'll do a step of 0.05. You'll see it now tells you the narration is 5 steps of 0.05. The other options we have setting step is that we can set the number of steps. We can say we want 6 steps, and I'll say there will be 6 equal steps of 0.0417. Alternatively, we can set a maximum step size, say 0.15, and it'll calculate there will be 2 equal steps of 0.125. Anyway, let's go back to the size of the step, and we'll say 0.05. The tool diameter is pre-filled in from our offsetting. And we have an option to select other features, but for this pocket we'll just leave it as such and add it to the machine queue. And there it is. If we go back into contour, back into local shape, select none. And now if we select the 3 slots to machine, move those to the local shape. This we want right the way through the material, so we'll go 0.4. The material is 0.375, and a step of, say, 0.1. On these cuts, I'm going to enable the ramping feature, and the ramp distance here, the total length of these slots is 0.127, and it's actually suggesting a ramp distance of 0.127, so it ramps the entire distance around the pocket. Let's just make it 1, And it gives us now a ramp angle that the tool is going to descend into the material. It's going to descend in at an angle of 5.7 degrees to a depth of 0.1 for each go round for a distance of 1. And we'll add that to the machine queue. And then finally, if we select local shape one more time, nothing. Select the outside contour, move it to the local shape, same depth, 0.4 and 0.05. For this one, because we're cutting this out of a sheet of aluminum, we're going to put some tabs in place to hold it by the tabs in place of the sheet of aluminum. And we'll say they're going to be 6 tabs, and we'll make the tabs 0.1 long. That's the length of the top of the tab. The tabs have a climb and a descent angle of 45 degrees. And the tab height is set to the step size, but you can increase it or decrease it. You can have the tab thinner than the step. So this will make it down to 0.04. So that's the tab is thinner than the final step. It can also be several times the final step, so all configurable. We add that to the machine queue as well. Now we can select all 3 items, the pocket, the slots, and the outside, and in this order, starting from the top. SL means it's a shape local. It's using a local shape rather than shape 0 because we've got selected geometry. And it's going to use tool 0 because we didn't select a tool from the tool table. We specified the size. We go ahead and generate that G code. And let's just switch to the toolpath, which gives us a bigger view. And let's first of all look at, so machine them in this order, the pocket, then the slots, and then the outside. If we look at the ramping, you'll see that the tool comes in and it descends into the material, each go around to the full depth. And on the final pass, it cleans up the ramp. And it does that. It'll do that for each of the slots because we switched the ramping on there. For the outside, you'll see the tabs. We made them 0.04 and the final step is 0.05. You'll see as the tool comes around the final pass, it'll lift, travel the length of the tab, and descend back down, leaving these little tabs in place to hold the part in the sheet of material that you can later punch out. And there's the pocket in the middle. So there's the machining strategy for the bracket using D2nc imported from a DXF file. Thank you.